Here's a system of linear equations in two variables. Problem 13 on the review sheet. Remember, when you're solving systems of equations, you are looking for that solution that solves all of the equations in the system. Here in this case, we have two equations, so we are looking for the xy pair that is a solution to both of those equations. And the method we use most often to find that pair is what's called the addition or elimination method. So we're going to make, for one of the variables, either x or y, we're going to make their coefficients additive opposites, so that when we then add together those equations, the y or the x variable will disappear, giving us a linear equation in one variable that we can solve. Since I want to make additive opposites, I need to have the coefficient for the variable, one of them positive, one of them negative, one of them plus, one of them minus. And I already have that here for y, don't I? So y would probably be the easier variable to eliminate at this point in time. What's the least common multiple for 3 and 5? Well, that's 15, isn't it? So what I would like to do is I'd like to make the coefficient of the y here negative 15, and the coefficient of the y here positive 15. Couldn't I make this negative 15 by multiplying that entire equation by 5? And if I multiplied this equation by 3, wouldn't that make the y coefficient here plus 15? So let's perform those multiplications. 5 times 6x is 30x. Minus 15y equals negative 15. Don't forget to multiply the constant by the multiplier you've chosen, as well as the x and y terms. 3 times 4x is 12x, plus 15y equals negative 27. And now I want to add those equations, because when I add these equations, the y terms disappear. I get 42x equals negative 42, a linear equation in one variable, x. Could divide both sides by 42. We get x equals negative 1. And we have 1/2 of the ordered pair that solves both of these equations. We have 1/2 of our solution to this system. And now we take that x value being negative 1, put it in place of x in one of the original equations, say that first equation, and we can solve for y. 6 times negative 1 is negative 6. If I then add 6 to both sides and divide both sides by negative 3, I get the solution that y equals 1. And we have our solutions to the ordered pairs. Excuse me, I get y equals negative 1. I was looking at that and thinking, that doesn't look quite right. That wouldn't work out for that equation if y had been 1. 3 divided by negative 3 gives me negative 1. So my ordered pair solution is negative 1, negative 1. When x is negative 1 and y is negative 1, that produces a solution for both of those equations. This is the solution to that system of linear equations in two variables. And remember what that means graphically. That means if we were to graph the lines related to these equations, the lines would intersect at this point, negative 1, negative 1. Remember, that's always what the solution to a linear system in two variables represents graphically.